Okay, welcome back to Dynamics ECS 429. And today you are with me, I'm Dr. Yasmin Sahur Hamid. So I'm going to share my screen, and today we're going to do topic 1 on curvilinear motion. So today we're going to do a topic on curvilinear motion. Okay, now can you see my screen?
Yes.
Okay, good. All right, so today is 25th October 2021, and this is week 3. So we're still in topic 1. However, we're going to focus on curvilinear motion. So topic 1 is still on kinematics. Okay, kinematics of particles. However, what we're going to focus on today is on curvilinear motion. Curvilinear motion. And what do you understand of curvilinear motion? What does curvilinear motion means? It means that a particle is moving along a curved path. Okay, that is what curvilinear motion means. Particle moving along a curved path. Okay, now, so for curvilinear motion, a very simple example that I can give you is, for example, that you're playing basketball and the ball is considered as a particle, and you throw it, you throw the ball, and you want the ball to land in a hoop in the net. So that is an example of a curvilinear motion. Okay, so for example, this is you. Okay, okay, this is you. Okay, and then you're playing with a basketball ball, and then there's a net here, as I mentioned, and you want to throw the ball and you want it land in this hoop, in this net. So this is what you call uh, a curvilinear motion, a particle moving along a curved path. Okay, now um can you give me some other examples that is related to curvilinear motion that you can see in your surrounding daily life? What else?
Moving downwards from a hill.
Moving downwards along a hill. No, when you move down along a hill, you're moving in a straight line unless you are flying off the hill. You're gliding off the hill. You're gliding, unless you are what do you call, jumping off the hill, yes. But because this particle, has a constant downward acceleration, okay, which is called g, and is also equals to what? Negative 9.81 meter per second. This is what you call free fall, free flight motion. uh, Last time you learned about free fall motion, but the motion is going straight. But now when you throw something, it has a curve. It moves in a curved path. It's not falling down straight, you know. So try and give me another example.
Riding a Ferris wheel.
Riding a Ferris wheel. Yes, riding a Ferris wheel. Yes, when you ride a Ferris wheel, so this is your Ferris wheel. Okay, is that how you look? How it looks like? I think so. And then it goes on a circular path. So let's say this is you, this is your friend, something like that, right? Going round and round. So this is you. Yeah, this is your friend. Wee! Yes. So it's going along a curved path, and this is the center. This is the radius. Yes. Riding a Ferris wheel is a curvilinear motion. That's correct. That's good. Any other?
Riding roller coaster.
Riding a roller coaster. Yes, riding a roller coaster. Yes, it's along a curved path. So let's say your roller coaster is like going like that. So this particle, this is you. Okay, let's say this is you riding along the screen. You say wee, can you go down like that, and then up like that? Yeah, yeah, yeah. Those are the examples of curvilinear motion. Okay, good. So there are many examples of curvilinear motion. However, just to make it clear, every example there is a method of solving it. So in dynamics, for curvilinear motion, there are three methods. There are three methods that you will learn for curvilinear motion. Okay. The first method is what we're going to learn today. And then on Thursday, we're going to do the second method. And then we're going to continue with the third method. So the first method is using the rectangular coordinate system. Okay. So rectangular coordinate system is the first method that we're going to learn today. And then we have the second method is uh, just give me a second, is normal and tangential. Normal and tangential. Uh, okay, this is the second method. And then we have radial and transverse. Okay, normal and tangential. And the last method is should be radial and transverse. Okay, radial and transverse. Okay, good. All right. So those are the three methods that we're going to do. Okay. All right. Okay. 1, 2, 3. Okay. Okay. So for today's method, we're going to focus on rectangular coordinate system. Okay. So for curvilinear motion, you have to pick which is the best coordinate system. You know, you have to pick the best coordinate system. What it means is when you get a question on dynamics, you have to choose, are you going to solve this problem using normal and tangential? Or are you going to solve this problem using rectangular coordinate system or radial and transverse? You have to pick which one is the best coordinate system. And the correct coordinate system, there must be only one lah. But how you decide is based on the question. Okay, so for today's class, we're going to focus on rectangular coordinate system. Yeah? So today's class, we're going to focus on rectangular coordinate system. So when you hear the word rectangular coordinate system, you must be thinking, okay, rectangular coordinate system, it means that it must have x and y coordinate. Okay, rectangular, right? So it must have an x, it must in the x and y coordinate system. Okay, that is right. Okay, so for a rectangular coordinate system, usually we solve problems that is related to motion of a projectile. Okay, this is the example that we're going to solve. Okay, someone just entered our class. Okay, right. Okay, now, so for a rectangular coordinate system, okay, the term is usually used for a free flight motion. Free flight motion. Okay, that's why the example that I gave just now was you're holding a ball, you want to put the ball inside the net, or you want to play baseball, or you want to play netball, golf, everything that involves a free flight motion is an example of a motion of a projectile. Other examples is like, for example, you know, at the airport you have baggage. Those baggage, they go through a conveyor belt. You know, baggage, let's say this is a conveyor belt, and then you have baggage, and then you're going to travel, you know, those baggage. Okay, and then what happens what happens? It will drop down here, right? Inside a container, right? And this container, they have wheels, right? And then this container will bring, where will it bring the baggage? Inside the aeroplane, right? So when this baggage falls like here, falls into this container, this is considered as a motion of projectile because it moves in a curve and is due to free flight motion. Okay, so this is also another example. Okay, another typical example. Okay, so the best way for us to understand this rectangular coordinate system is we need to draw a very big diagram of our x and y axis. So can you please in your book draw as big as you can? Okay, okay, so here we have x axis and here we have y axis. Okay, so let's say you have a particle. Okay, this particle is gonna fly from this position until here, for example. Okay, so number one, you must know what is the coordinate for that point. So let's say this is our initial point. So when you have an initial point, you must have a velocity. So let's say this is our velocity v naught. Okay, and this is our final velocity v. Sorry, let me draw it. V. Okay, sorry, v. So our initial velocity is v naught. Our final velocity of the particle is v. So then what you need to do is you need to resolve it into components because we're solving this problem using the rectangular components. So everything has to be in the x and y axis. Okay, so this has to be in the x and y axis. So this will be v naught x and this will be v naught y. And this will be Vx and this will be Vy. Okay. All right. So these are the 2 points of the particle, the initial. So this is the what you call initial position, and this is what you call the final position. Okay. All right. So then this position must have a coordinate. Okay, your x and y coordinate, right? So since it's initial, we call it x naught, y naught. And since this is final, we call it x and we call it y. So this will be our x naught, okay, distance, and this will be our y naught distance, okay. So for our final position, this will be our x coordinate, and this one will be our y coordinate. Okay, are you drawing this, guys? And due to free flight, they must have a gravity. So A acceleration equals to G, and we know G is also equals to negative 9.81 meter per second squared. Okay, all right. Okay, done. Have you finished drawing that? Are you drawing that, guys?
Still drawing, madam.
Tell me when you are done. I'm drinking my 3-in-1 Nescafe Gold gitu. Kalau ada apa? Daun pandan kan? Potong-potong letak dalam ni. Lepas tu ada bunyi air terjun kat belakang. Oh, macam iklan Nescafe Gold tu kan? Kelakar pula. Anyway, are you done?
Yes.
Okay, good. All right. Now, so once you have understand this drawing, you should be able to solve the questions related to it. Okay. Now, let me go up. So, if you see this projectile, since it's using the rectangular coordinate system, we need to resolve the motion of the particle in x and y direction, it means that we must have an equation for horizontal motion And we must have an equation for vertical motion. Okay, because we are solving this problem using the rectangular coordinate system. Now, for horizontal motion, what do you think the acceleration would be? Can you guess? Do you have an acceleration in the horizontal mode in x direction? Do you have?
No.
No. So, when you do not have, the acceleration will be 0. Now, for vertical motion, do you have the acceleration in y direction?
Yes.
Yes. And it will be,
The gravity.
yes, negative g, which is also equal to negative 9.81 meter per second squared. Okay? All right, good. Now, remember, because this involves a constant downward acceleration, this one, sorry, this one is a constant downward acceleration. So it means we need to use the formula with constant acceleration. So we need to use the formula with constant acceleration. Now, do you remember the formula for constant acceleration? V equals to V naught plus ACT, S equals to S naught plus 1 over, am I right? Sorry. S equals to S naught plus V naught T plus 1 over 2 ACT squared. And one more is what? V squared equals to V naught squared plus 2AC S minus S naught. Remember that formula?
Yes.
Okay, good. Now, you have to use this constant acceleration formula. However, we need to write it down. We need to write it down based on the horizontal motion and vertical motion. Okay, so if we write down based on the horizontal motion, okay, it will be V equals to V naught plus ACT. So when you write it down based on the horizontal motion, what happens to AC? AC becomes 0. So you're left with V equals to V naught. Do you understand? Okay, now for the second formula is S equals to S naught plus V naught T plus 1 over 2 AC. Sorry, this is AC, yeah? AC T. But because we're using the XY coordinate, you have to write it in terms of XY. So what would it be, guys? It will be, what would it be? It will be X equals to,
X naught.
good. X naught lagi. V naught T plus 1 over 2 ACT squared. Now, this one acceleration also becomes 0. So you're left with X equals to X naught plus V naught T. Okay, and our last formula is V squared equals to V naught squared plus 2AC S minus S naught. Sorry, no longer S. It will be X minus X naught. So since this is also 0, you're going to be left with V squared equals to V naught squared. However, V squared equals to V naught squared also equals to V squared equals to V naught. Sorry, there's no longer a square because you can cut it out. So it'll be V equals to V naught. So you're left with this formula: first, second, and this, oh sorry, and this third one. Okay, number 1, number 2, and number 3. However, number 2 and number 3 is the same, right? Is the same. So what is saying here? What do you understand here? The final velocity equals to the initial velocity. However, can you read this? What does it say? What does this say here? Can you read this?
Horizontal.
Horizontal. So it means you have to have V has to have a X so that you can differentiate it. So this one also must have an X. This one also must have an X. Understand? And this V naught also means the horizontal, it means the velocity for horizontal. Okay, so you need to add the X. So you don't get confused with the vertical one. So here what it means is the velocity for the final equals to the initial velocity. But for what? In X direction. Understand? This means in the X direction. Okay, in the X direction positive. It means these are in the X direction. Okay. Okay, now can you guys try to do the same for the vertical motion and then we can check. Do the same for the vertical motion and let's check your answers. Okay, write down the basic kinematic equation for constant acceleration and then replace the velocity, replace for vertical motion in y direction and then replace acceleration with negative g. Okay, why don't you do that? I give you 30 seconds to do that quickly. All right. And then we check together. Okay. Okay, dah. Dah ke? Let's check how you write it down together. Let's check, yeah. Okay. So V equals to V naught plus ACT. Okay, V naught plus ACT. Okay, so when you use this equation for vertical motion, you'll get what? V what?
Vy.
Okay, Vy equals to what? V naught in the
Y.
bracket. Yeah, but V naught. Please don't forget, eh? Okay, and then since our acceleration is negative, so I just put negative GT. Okay, are you okay, guys? Okay, for the next one, Y equals to Y naught plus V naught T plus 1 over 2 ACT squared. So when I change it, it will become Y equals to Y naught plus what? V naught, but in the bracket, outside the bracket YT, and then negative 1 over 2 GT squared. And the last one, V squared equals to V naught squared plus 2AC Y minus Y naught. So it will become Vy squared equals to V naught inside the bracket and then outside bracket Y squared minus 2g y minus y naught. Okay, now, so this will be our other formulas that we're going to use. The third formula, fourth formula, and this is third. No, this is the fourth, sorry. This is the fourth, this is the fifth, and this is the sixth. Okay? All right, guys. Are you okay, guys?
Okay, madam.
Okay, now, all right, let's, so basically, the step for solving questions that is related to motion of projectile is we need to establish the coordinate system. So you establish the fixed x and y coordinate system, and then after you have established the fixed xy coordinate system, you sketch the trajectory. This one, the picture you see here is what you are sketching, and then you see that there are 2 points on the path, so you identify the 2 points, and then you list out what are the unknowns and all, and then what are the variables given, the unknowns is given. Okay, all right, good. Now, and then you use the basic kinematic equation and you come up with the new horizontal motion and vertical motion equation. Okay, all right. Now, if you understand that, we can start doing one question together and try to solve it. Okay, copy this question. It's good that we try to solve this together. Because based on experience, I find it students are better when they solve the problem together with the lecturer during the class. Okay, if I quickly go through the answers of a problem, I'm afraid that you might be lost. So usually what I do is I will give a very in-depth explanation of 1, 2, 3 examples like that. And once you understand, if you look at any other tutorials, you should be fine. Okay, are you okay with that way?
Yes.
Okay.
Yes.
Okay, but I need your concentration. Okay, I need your full concentration. I need you to copy what I write, everything. Okay, and listen.
Abang mandi sini. Abang nak bawa ni. Abang nak bawa ni. Abang nak bawa abang pergi sini. Ya.
Okay, have you finished copying?
Not yet.
Okay, tell me when you're done, Saja tambah colour-colour sikit. Okay. Tell me when you're done, I'll enjoy my coffee.
Mak, jom. Go back. Okay, bawa Mak. Abang go back. Mak cepat, Abang. Mak, jom. Let's go back. Bye-bye, Abang go back. Ooh.
Done?
Done.
Okay. Now, let's read this question together. A sack. Okay, a sack ni macam guni tu lah. Guni yang you nampak yang warna yellow ni. A sack slides off the ramp with a horizontal velocity of 12 meter per second. So the sack ni dia slide around off this ramp and dia dah ada horizontal velocity. So untuk soalan ni, for this question, the velocity is already in the horizontal direction. It means you tak perlu resolve lah. Sometimes if dia bagi the velocity at the angle, you need to resolve in x and y direction. But for this one, the velocity is already in x direction. If the height of the ramp, so dia dah bagi height, the height of the ramp is 6 meters from the floor. Determine the time for the sack to strike the floor. So dia nak tahu the time taken for the sack to travel from A to B. So what is the time taken from A to B, and then determine the range R where the sack will pile up. So maksudnya when the sack ni turun je daripada ramp ni, dia terbang from point A jatuh ke point B. Alright, so dia nak what is R. So when you see this kind of question, you must understand, number one, this is a curvilinear question.
Let's go back.
And you must understand that for this question, you need to use the motion of projectile. Okay? Why you need to use the motion of the projectile? Because ada free flight motion. Okay? And when you see this question, this one, you can resolve the components into the x and y coordinate system. Okay. So now, the difference between this diagram and the one that I have given previously, if you notice previously, the initial is V0, V0 X, V0 Y, and the final is V, Vx, Vy. For this question, what will be the initial? Class?
A.
Yes, the initial will be A, okay? So you need to make sure, the important thing is from the basic equation, you have to make it in terms of point A and B. Okay, number one, let's identify the coordinate. What should coordinate A be?
0, 0.
Yes, so coordinate A should be 0, 0. Okay, all right. Now what is coordinate B?
R -6.
R -6. Kelas nampak tak kenapa -6?
Nampak.
Sebab di bawah.
Okay, good. Okay, nampak ke bawah. This is very important because if you miss this negative, even though you're so confident that you get your answers correct, but your method might be correct, but your answer will be wrong. Okay, so don't make careless mistakes. I like to write now. Okay, if coordinate A is 0, 0, coordinate A itu apa? Coordinate A itu adalah sebenarnya apa? Adalah?
Initial.
Tak, how do you label coordinate A?
Origin.
XA, YA. I want you to be clear this one. How do you label coordinate B? XB, YB. Okay? All right, this has to be correct, you know. If you don't label this correctly, then your formula will be wrong. Okay, now. Next. Okay, what other information do you have? You have the velocity, the initial velocity, right? So the initial velocity will be what? V what?
X.
X.
VA, but and then X will be outside here. So VAX equals to 12 meter per second. Is that right? Class? That's right. Now, do you have VAY?
No.
No, VAY is 0. Okay, VAY is 0. Do you have VBX?
$12.
Okay, why do you say VBX equals to 12? Can you answer me? Siapa yang answer 12 tu? Kenapa VBX you kata 12?
Sebab tadi buat V initial equal to V final.
Yes. Okay, have a look back at this equation. Can you see back the equation number 1? Okay, if you read the equation number 1, what is it? The final equals to the initial. And for this question, what is our initial? Our initial is A and our final is B. So if you look back at the equation number 1 is what? Vx equals to V naught x. If you look back at equation 1, Vx equals to V naught x. For our case, Vx is equals to what? V what?
B.
VB equals to
VA.
VA.
yes. Do you understand? That's why our VB equals to, but don't forget, this is in the x direction. So that's why VB equals to VAX. So that's why your friend has mentioned that VB, the velocity of B at x direction is the same. You get it, guys? Boleh? Boleh. Okay. All right. Okay, good. So VBX equals to VAX. Okay, good. All right, now. So now we want to solve this problem. One more information we have. Acceleration equals to negative G. Okay. All right. Now, so to solve this problem, which formula you want to use? Right now, you want to find the time. So let's look back at this equation. Now, which formula has time? If you notice, formula 2, 4, and 5 has time. But which formula you want to use? Can you please tell me? Formula 2, 4, and 5 has the time, has t. But which formula you want to choose to solve this problem? Do you want to use number?
Formula 4.
Okay, why you choose formula 4?
Because it don't have the displacement. Since we don't have the displacement yet, so we should use the 4 formula.
Displacement, the coordinate. We don't have the coordinate yet. Okay, have a look at formula number 4. Okay, do you have Vy?
No.
Do you have Vy? Yes or no? For vertical.
We have VAY equals to 0.
Okay, so you have Vay equals to 0. So if this, do you have V not Y? No, you don't have, right? If you use equation number 4, what will happen?
Two unknown.
You have two unknown.
Okay. Another equation, please.
Equation 2.
Equation 2. Class. Okay, why do you say that just now you do not have V not Y? Can I repeat the question again? Do you have Vy?
No.
Okay. Do you have V not Y? Now,
No.
okay, maybe you are confused. That's why what I suggest is you change everything according to the formulas. So right now your Vy will become what? VB, right?
VB, yes.
VB, Y. Your V not Y will become?
VAY.
Okay. And then this one will become the same. So why don't you do that and then tell me again what you decide, which formula you want to use. I want you to think how to solve this. Oh, sorry, dia mengecil pula. You need to think. Please don't let me give you the answers. I want you to think to solve this. Yeah. Okay. Now tell me again. Now tell me again. What have you decided? Hmm.
The fifth equation,
Yes. Why is the fifth equation better?
because we have all the information except for
Yeah.
time.
Yes. Why wasn't the equation number 4 suitable? Because you will have two unknowns, right?
Yes.
Yes. If you use equation 4, what was the two unknowns?
VBY and T.
Yeah. So now if you use equation 5, you'll be left with only
T.
T. Yes, good. So let's use equation 5. I always like to write again so that I don't make mistake. Okay. So what is our y?
Negative
Negative
6.
6.
Okay, now what am I doing here wrong? I did something wrong here. I'm supposed to write this one as YB, right? And this one I'm supposed to write as YA. That's why. That's why I can make careless mistakes because I get it wrong. So this should be YB and this should be YA. Okay, you must use the correct coordinate. So what is our YB? Negative 6. What is our YA? 0. What is our VAY? 0 minus 1 over 2, 9.81 t squared. Okay, can you give me what is the answer for t? T is the distance travel for the particle from point A to B. The time, the time. Not sorry, not the distance travel. The time taken. Can you give me what is the time? What is the answer? Yes. What is the answer, ladies, gentlemen, ladies and gentlemen?
1.1.
Yes. 1.11 second. Okay, that's correct. Okay, good. Now, next question. What is the next question? Calculate R. Okay, now. So, which formula you want to use to find R? Now, have a look. What is R? What is the coordinate for R? R
XB.
at XB. So, when you see the word XB, of course, you should not be looking at vertical motion. You should be looking at horizontal motion. Okay, jangan don't think too long. Okay, you should be quickly think about it because this is R is the XB. Since R adalah XB, you should look at the horizontal motion. So from the horizontal motion, equation 1, 2, 3, which one you want to use? Of course, it must be equation number 2. Betul tak? So write down the equation number 2. Okay, senang je. XB equals to XA plus VA x t from A to B. So what is our XB? Our XB this time is R. Our XA is 0 plus our velocity is 12 and our time that you have calculated is 1.1. So what is our R?
13.32.
Okay, meters. Yes, that is correct. Okay, good. Okay, so now obviously this question is actually easy, but students can make mistakes if they do not identify the labels properly, the coordinates properly. Okay, if you don't identify the coordinates A, B properly, and when you put into the equation, the way you define VBY, VBX is not done correctly, you can make a lot of careless mistakes. But if you really understand the coordinate system, the coordinate system, when I explain this one and the fundamental formula, supposingly whatever coordinates A to B, A to C, or initial to B, whatever they use, you should be able to get the answer. But that's why we try to do this example slowly, carefully together. Okay, so do you understand, guys? So if I give you another question, something like this, I'm sure you can answer it. Okay, and you can answer it less than 5 minutes. Let's see, boleh tak kita try? Yang penting you faham concept. Do you understand the concept right now? Class, you understand?
Boleh.
Boleh. So
Yes, ada.
just remember let's say this is VA, this becomes VAX, this becomes VAY, and this one, this is VB, this is VBX, and this is VBY. Okay, all right. So as long you understand that, and you will have a velocity, and for this question, you don't need to resolve the velocity because it's already given the horizontal velocity as 12. But in the next question, I will give you an angle, theta. If I give you the theta, you need to resolve it. Okay? All right. Let's try. Okay, you must understand, whatever the unknowns can be theta. Theta is the direction, the unknowns can be VAX, can be V naught, can be coordinates. The unknowns can be any of these variables, but you must be able to figure out how to find that unknowns. Okay, right? Okay, are you okay, guys? Can we go to the next question?
Yes.
Madam.
Ada soalan? Tak ada.
Tak ada.
Okay. Okay, if possible, I do not like my students to miss this class. When you miss one class of me teaching you the motion of projectile and then you want to learn yourself through the video, okay, it's fine. But make sure you do watch the video from beginning to end and do the exercise yourself, okay? Okay. Are you okay, guys? I hope I'm not going too fast or too slow. Okay. Are you copying, guys? Let me know when you finish copying. Okay, try this example. I'll give you around 2 and 3 minutes to do. Try yourself first, and then we will discuss together how to solve it. But make sure you do it. Okay, try. Okay. And how are you going to do it? First, you identify the coordinate system for the origin and the final position. And then you list out the unknowns. And then you notice that because we're using the rectangular coordinate system, you need to resolve the initial velocity in the x and y coordinates. So you need to find Vox and Voy. And how to do that? One must be, so Vox will be the initial velocity multiplied by cos theta, and for VOY will be V naught multiplied by sine theta. Okay, and then um you figure out which is the best formula to solve the problem. Okay, all right, I give you 2-3 minutes to do this. Boleh?
Boleh.
Okay, all right, make sure you get a perfect answer. I will be back. Okay, I mute my mic first. Okay. How is it? Are you trying? Hello, guys. Can you hear me? Hello.
Yes.
Okay. Are you trying?
Yes,
Are
keep
you?
trying.
Okay. So try. While you try, can I call your? Can I call your apa? Can I call call your names
Attendance.
for yes, call your names for attendance?
Boleh, boleh.
Okay, alright. Okay, ni kelas C3 SC3 Ke?
Yes.
C3, okay.
It-
Hah?
C3 madam.
C3 Okay, Adam Abu Basar. Adam? Adam?
Ya, saya.
Okay. Ahmad Irfan?
Ya, saya.
Ahmad Irfan?
Saya, madam.
Ahmad Mustaqim?
Saya, madam.
Alif Haikal?
Saya madam.
Amirul Iman?
Saya madam.
Ashraf Haziq?
Saya.
Dayang Nur Faiza? Saya saja je. Dayang Nur Zafira?
Saya, madam.
Okay. Fariha Afrina?
Saya.
Fifi Farhana?
Saya, madam.
Lenita. Lenita ni macam teringat lah. Dia janji nak buka kamera tunjuk bilik dia kan? Lenita, are you ready to open your camera at the end of the class? Lenita?
Actually, madam, hari tu saya babysit.
Oh, you babysit. So hari ni dah tak babysit
ya.
lah. I see. So hari ni boleh lah I tengok your face. Kejap lagi nanti at the end of the class Okay.
Okay.
Megat Hakimi.
Saya madam.
Okay. Muhammad Akil. Muhammad Akil. Muhammad Akil. Okay. Mana pergi Muhammad Akil? Okay. Alright. Ali, Maya suruh bawa tinggal bawah. Okay, Muhammad Akil, where are you? Sekejap, mana pergi? Okay. Muhammad Faris.
Saya, madam.
Okay, Nur Faiz. Muhammad Nur Faiz.
Saya madam.
Muhammad Zakwan. Muhammad Zakwan.
Dia kata dia dah WhatsApp madam.
Dia dah WhatsApp saya. Okay. Dia WhatsApp saya apa Okay, tak apa. Dia dah WhatsApp saya. Dah WhatsApp tapi tak tahu apa. Lupa kot. Ataupun tak sempat baca atau yang mana satu. Sebab ramai kan. And you all kan. Maira Shazana.
Saya, madam.
Nabiha Zafran. Nabihan.
Ya, doktor.
Nur Aisyah.
Saya, madam.
Nur Amira. So abang.
Saya, madam.
Nur Balkis.
Saya, madam.
Nurul Atika.
Saya, madam.
Syekh Abu Hassan.
Saya, madam.
Okey, ni adalah C3.
Pasti datang. Tak boleh.
Okey, Nur Alia Mashita. Nur Alia. Nur Alia. Nur Alia Mashita binti Ahmad. Tak ada. Mana pergi?
Jangan, Mat. Jangan, Mat.
San Nur binti Nordin. San.
Saya, Madam.
Siti Aisyah binti Arbain. Siti
Saya,
Aisyah.
madam.
Maisara binti Yusli.
Ada, doktor.
Nurul Iza binti Zainal.
Saya, doktor.
Okay, so ada 3 orang. Ketua kelas. Mana pergi diorang ni? Ada seorang ni dah WhatsApp. Okay, where are you? Okay, alright. Okay, now. Boleh kita start discuss solution? Ready? Ready Saya share screen balik semula so that we can discuss the solution together. Okay, can you see my screen?
Yes, doktor.
Okay, now. The chipping machine, so ni adalah chipping machine. Chipping machine ni maksudnya macam dia chip apa pokok-pokok wood ni. Lepas tu lepas dia dah chip dia potong dia hancur-hancur dia terbang. Dia ni lah macam cannon lah sikit macam terbang. So dia eject wood chip tu at the initial velocity of 7.5 meter per second. So the tube is orientated 30 degrees from the horizontal. Determine H. How high H the chip strike the pile if at the instant they land on the pile 6 meters from the tube. Okay, panjang 6 meters ni saya tak tulis. 6 meters ni adalah, sorry, dari sini ke sini. Okay. Alright, 6 meters Oh sorry, bukan R. 6 meters. Okay, now, so let's define the coordinate. So coordinate kita apa? Dekat origin ni. What is the coordinate?
0, 0.
Okay, 0, 0. What is the coordinate at point A?
6.
6 meters.
Yes.
And then,
Negative H.
salah. Your coordinate A is kat sini.
Negative 1.2 minus H.
Negative 1.2 minus H.
Kejap Sorry abaikan Alim. Bawa Ahmad keluar Alim.
Tak boleh. Tina suruh Ahmad nak.
Tak. Pergilah ajak dia main kejap. Go. Okay. Sorry. Point A apa? 6 dengan apa?
Negative H. Minus H.
Minus H salah.
Minus
Apa?
1.2
Minus
minus
H salah. Lagi satu? Apa?
1.2 minus H.
1.2 minus H.
Kena
Salah.
negative sign dalam bracket.
Negative
Salah.
1.2 minus H.
Negative 1.2 minus H. Salah.
Positive H.
Negative bracket 1.2 minus H.
Negative 1.2.
Negative
Plus
masuk
H.
bracket 1.2 minus H.
Negative. Sekejap. Lagi sekali.
Open bracket
Bracket.
1.2 minus H. Close bracket.
Okay. Ini adalah jawapan yang betul. Okay. Why? Right now, you nak height ni kan? You coordinate ni height. Height dia, you nak height ni. You nak height ni sebenarnya. This height. You want to find this height. So this height is actually apa? Is actually this height is actually 1.2 minus H. Tapi sebab dia berada di bawah paksi X, so you kena tak negatif. So end up dia akan jadi negative 1. Dia akan jadi negative 1.2 plus H. Alright, inilah jawapan dia. Betul ke ni? Negative 1.2 plus H. Negative 1.2. Oh ni salah ni. Ni apa tadi you bagi tadi?
Minus H.
Minus H. Betul lah. Okay, nampak tak? So the correct answer is this one lah. Okay, so you punya coordinate untuk point A ni adalah 6 dengan negative 1.2 plus H. Boleh tak? So if you get the coordinate system wrong, the whole answer final is wrong. But maybe your method of solving is correct. So you need to really make sure that you do not make the mistake in the coordinate system. Are you okay guys? Boleh? Siapa yang tak faham? Can we continue? Boleh? Can we continue? Any? Boleh?
Boleh.
Okay.
Yeah.
Alright. Okay. So, now, since everything must be in the X and Y components, kan, sebab rectangular components, you must write this. You dapat markah kalau you show that you resolve ni. Maksudnya you buat ni, VO X, you cari VO Y. Alim. Sekejap sorry anak Alim. Nak buat macam mana kat rumah Okay, so V not X. Sekejap bagi I satu saat je. Hello? Okay, I'm back. Sorry Can you hear me now?
Yes.
Okay.
Yes.
Tadi bunyi marah-marah tu semua tak dengar kan? Okay. Tak dengar kan tadi?
Tak.
Okay, Alhamdulillah tak dengar. Okay, so V naught X, you need to resolve it in X direction. It will be what? V naught what? Cos or sine? Class?
Cos.
Cos
Oh.
30 degrees. So dapat berapa? V naught cos 30 degrees dapat apa? And then V naught Y. Dapat berapa?
6.5 for X.
Okay, yang bottom one dapat apa?
3.75.
Okay, good. Okay, so that is correct. Okay, now what is the question? The question is they ask you to find how high H the chips strike the pile if at the instance they land on the pile 6 meter from the tube. So dia nak suruh cari H. So now from this one, which equation you want to use? Wait. Sekejap Kembali balik ke formula kita ni. Okay, now from here, tell me which equation you want to use. Tadi dah bagi masa lama kan untuk try to solve this problem. I have given you a long time to do this. So which equation you want to use? Can you tell me?
5.
5. Okay, so if you want to choose equation 5, what will happen? Okay, let's see if you want to choose equation 5. Okay, let's see. So you want to choose equation 5. So it will be y equals to y naught plus v naught. Okay. Y. Okay, v naught y t. And then minus 1 over 2 a c t squared. Now, what is y? Y is the initial, the final. Is at point A. Okay. So do you have YA?
No.
No.
You don't have YA, but it's in this what your this is this is XA, this is YA, right? Okay, So your YA is in terms of X, in terms of H, which is negative 1.2 plus H. And then what is your Y naught? 0.
0.
What is your V naught Y? And then okay, so what is it? What do you see here? You have how many unknowns?
2.
So it means what are you gonna do if you have these two unknowns? How are you going to solve it?
T.
Okay, so if you want to solve T first, is there a way for us to solve T and get the answer straight away? Using what formula?
Formula 2.
Formula 2.
Formula 2. Okay, so let's write formula 2. So formula 2 is X equals to X naught plus V naught XT, but X is become XA. Do we have XA?
6.
6. And X naught is 0.
0.
V naught X is 6.5 and then T. So you can find T first. And what do you get T?
I found it.
0.92.
So 0.92 seconds. So what you do is you put 0.92 into this equation here, in T in this equation, and then you find me H. So can you find me what is H? So what do you get for H?
0.5.
0.4 ataupun 0.483, lebih kurang lah. Okay. This one maybe if you use 0.923 seconds lah. Okay. Either one lah. So those are the answer, yeah. So correct. Okay. Senang tak? Senang kan? Okay. As long as you understand, you should be fine lah. Okay. So I will give you one more example for you to try, and I will give you the answer, but we will not discuss in class. Boleh tak?
Boleh.
Siapa call? Sekejap give me a second. Hello Reza. Tengah kelas. Okay, tak apa, cakap lah. Satu individu. Kan I suruh betulkan tu. Semua individu Reza. Sama. Kita buat macam dulu je. Sama je. Reza, nak solution tutorial tu? Bukan yang you share. You share kat student you. Student I tanya pula. Okay. Thank you. Okay. Okay, okay. All right. Now, this one more last question I give for you. Okay. The track for... Are you okay, guys? Are you tired copying?
No.
Okay, good. Because I prefer you copying, because I'm afraid if I give you a 2-hour, lecture talking with my slide, I'm afraid that you're not gonna sit down. You're gonna go somewhere. Maybe you're gonna sleep. You're not sleeping, You're fully focused, Okay. It's good that you do the examples together, yeah. So it should be when you get a question to do by yourself, you can think by yourself. Okay, don't rely on the solution. Don't look at solutions while doing any questions. It's not going to help you. It's better you try. You don't know the solution. You don't know the answer is correct or not, and then you give me to check. That is much more better. Anybody tengah tengok The Voice? Tak ada. Tak ada geng ya? Cerita Korea. You all tengok cerita apa? Masih Squid Game ke? Ui, fokus betul you all. Okay, tak apa. Alright, okay. Dah? Are you copying? Or draw for you?
Exotic brand. I put my graphics very hard. It's not that reality. What should we do in this game?
Okay, I dah bagi you the answers.
Alright, what do we need to do in this game?
Okay, you can try this at home. Okay, can you tell me after you finish copying?
Yeah, let's just do it without watching. Whoa. Ready? Should we speed up?
Okay, dah habis copy dah?
Should we speed up? Apa?
Belum.
Dah.
Dah. Okay, now. So this question you can try later. And I've already given you the answer. So that is fine. And I'm sure it's very easy for you. Okay, you can do this. Petik jari je dah boleh buat dah. Senang dah faham dah. Okay. So it's not difficult this kind of questions Okay, so you can try. Okay. Now, let's go back at the okay. Wait. What am I looking for? Oh no. No. Okay. Now, can you see my screen, Evans?
Yes.
Okay, so for today's class, I want you to fill out today's attendance. So today's attendance is the lecture, week 3 attendance class lecture. So you click on the attendance for today and just write down what you learned today. So you can say that for today's class, you learn about motion of projectile. You understand that it involves free flight motion, is a curvilinear, moving in a curved path, whatever. What do you understand? You use basic kinematic equations, but however, you have to come up with a new formula for horizontal motion, vertical motion, whatever you understand. Okay, so this is important for us to determine whether you really understand what the lecture has taught you. Okay, all right. So go back here, so you can while waiting you can fill out the attendance. So basically, for if we look back at the lesson plan, just to tell you important materials. Okay, this one, can you please re-download this lesson plan, because I have made some additional changes. I have include assignment. The topic of the assignment is which will be in week 6, and then test will be in week 8, and then the individual assignment will be in week 11, and then let's look at the week 3 punya learning outcome. So basically, week 3 punya learning outcome, students should be describe the motion of the particle traveling along the curved path. So that one you have done. And then you'll be able to relate kinematic quantities in terms of rectangular components, okay, of the vectors that you have done. And then you should be able to analyze the motion of the projectile. Yes, that one you have done. And you are able to calculate the position, velocity, and acceleration of the particle undergoing curvilinear motion. Okay, however, using tangential, normal, and radial and transverse, this one we will postpone, we will do this on Thursday. Okay, so maybe we will have time for normal and radial only. Maybe transverse coordinate we will bring to the other week, depend on how fast we can do it. Okay, so as I mentioned just now, remember in our hold on, remember I told you there are 3 methods to solve this. We have done the rectangular coordinate system. We are left with normal, tangential, radial, and transverse, these 2 methods. Okay, that one we will do this Thursday. Okay, all right, so those are the learning outcome for kinematics of particle for curvilinear motion. Okay, everything is individual. The assignment is individual, the project is also individual. Everything is individual. Okay, so and then what you can do is you can open week 3 punya kinematic of particle here, already available for you, the what do you call, already available for you the notes, the lecture notes from Beer Book, also available in YouFuture already, some videos, and also available, the tutorial also available. So if you click here for curvilinear motion, you will notice here are all examples related to curvilinear motion that you can try. So, and students can try these examples, okay? And I promise you that I will give you the answer. Maybe by the end of this week, I will prepare all the answer for all the beer textbook, and I will put it here so you can check easily the answers. Okay, going back here. Okay, what else? My course. Okay, what else? So everything's here. And then if you want the link to the video, so if you want to see Dr. Raizam's video, you just click his name, and he has already available his lecture video in a drive. But for me, I put it in YouTube. So each week you will click. So maybe after this class, I will download it and put it here. So you just click to the video according to the week, and then you will find the video. See, it's already available in YouTube. Okay. All right. Okay, so I can see here for last week video there are 21 views. So usually maybe these are the students that want to go back and look back at the videos again, and try to understand better. So for those who miss this class and unable to catch up, need to look back at the understanding, can go back to the video later, which I will try to download by today. Okay, inshallah by today after I stop this recording, I will download it. Okay, anything else you would like to ask? We will have a diagnostic test this Friday. It's just simple maths question. Usually you are given 1 hour to do it, but you can do it anytime during the day. Maybe you want to do it at 3 o'clock, at 10 o'clock in the morning. Just spend your time to do it, and it will be in your future. We will share you the link. Okay. All right. So is there any other question? I will stop this recording. Yeah.